Right, I'm just going to demonstrate three questions in 1.3. Some of the students reported that because geometric sequence and series is it's a new section compared with a review of arithmetic sequences and series. So when you encountered the questions in the exercise, you might find it's rather difficult. So then let's see whether or not I could demonstrate a number of questions here. All right. Okay, so now let's take a look at this one. This question number B. This is basically if you just use a formula, it should not be a big deal. But because of the root of 3, so some of you might encounter some difficulties if you only use your calculator, because it will give you a decimal. So let's see how I can do this. So here R, the common ratio should be A2 over A1. So in this case is root of 3 over 3. So this one is a number that is smaller than 1 because the root of 3 is definitely smaller than 3, that's for sure. And smaller number divided by larger number, so this number is smaller than 1. So in this case, you will want to first of all consider that the A9 it's a number going smaller. So the A9 for sure will be smaller or much smaller than 3. All right. So now here we can just plug the formula, plug the number into the formula. So A9, that equals to A1, multiply the common ratio, and then it is the n minus 1, so that means it is the 8. All right, so then A1 is 3, great, okay, that's not a difficult number. Then R now is the root over 3 divided by 3 to the power of 8. Now here, if you go into your calculator to get a root of 3, that's a decimal, divided by 3, that's another decimal, and then eventually look at the answer key, you might think, what did I do? So the point here is that don't even bother with the calculator, just use your number sense to understand how this radical is being calculated. So this means that is 3 multiplied by root of 3 to the power of 8 divided by 3 to the power of 8, right? So the 8 distribute both top and bottom. And the root of 3 to the power of 8, that is 3 to the power of 4. Because the root of 3 to the power of 2 and to the power of 4, that equals to this one. Now, root of 3 to the power of 2 is 3. So therefore, this equals to 3 to the power of 4. So that is this one. All right. So now, this 3 and 3 to the power of 8, that also could be canceled. Then this becomes 7. So now we ended up with 3 to the power of 4 at the top, which is our numerator, and then 3 to the power of 7, which is in our denominator. So then what's happening here? Then that means this becomes that. So that means this is 1 over 3 to the power of 3, and then of course that's 1 over 27. All right, okay. Now next question I picked up is that this F. So then you can try E, which is the same thing. So this one here, again, we need to use number sense because now we're calculate n. So some students says, well, because n is in the power without logarithm, how can I calculate that? Well, even grade 9 you did it, because if the base is the same, that means the power will be the same. So that means if a to the power of n equals to b to the power of n, that means a must equal to b. Then a must equals to b. Another way to say that, if a equals to the power of m and equals to a to the power of n, if the same base, then therefore m must equals to n. So if you wanted to calculate this n, you just have to make the base the same. Then you will know m equals to n, and then you can solve it. So let's see what's going on here. So now again, this is r equals to 1, 0, 2, 4, which is a2 over a1. Well, very obvious, this is 1 over 2. Okay. All right, so now what's going on here? So then this one, the last term is 1. So that means the last term is equals to a1 multiplied by r to the n minus 1. So then this one here, now we're trying to calculate the n. So that's, some student says, oh, I cannot do that because it's in a power. Well, let's see. Of course you can. By doing what? So here, my L, my last term is 1, so it's over here. My A1, I know this is 2048. I also know my common ratio is 1 over 2, and then that's n minus 1. So okay, from here, what do I do? All right, so what do I do is that obvious. If you know this number, means you're very familiar with this number. Now, some of you have taken computing science, then you know this number equals to 2 to the power of 10. This is a very significant number in computing science, all right? So then this is equals to 2 to the power of 11. Wow, okay. So in this case, now let's go back to the question. This now becomes 1 over 2048 equals to 1 over 2 n minus 1. Now this means 1 over to the power of 2 to the power of 11 equals to 1 over 2 to the power of n minus 1. Right, well then why don't we rewrite this? That means 1 over 2 to the power of 11 equals to 1 over 2 to the power of n minus 1. Bingo. So that means the n minus 1 here is for sure equals to 11. Otherwise, this number will not be equal. So n minus 1 equals to 11. Therefore, n equals to 12. Okay. All right. So now the last question I thought I should demonstrate is J. Is J. Okay. Now let's see what kind of strategy I can do J. The different strategies, but what I did was, okay, so A25, that means A25, that equals to A1 multiplied by R to the 24. A to the 31, A31, that equals to A1 R to the 30. All right. Now here what I did was I'm just going to divide my left-hand side, and then I divided my right-hand side. So in this case, this A1 is not in my consideration anymore. I don't even care about A1 because it can be reduced or just canceled. So then in this case, I know this number, I know this number. So then that is 12. I'm going to write it here, okay? So that means that's 12 over 96. And all of you know this is a cancel, means 1 over 8. And then this one here means R24, R30. That means 1 over R to the power of 6 down here. All right. And then this one, in fact, this becomes 1 and 8. 96 divided by 8 is 96 divided by 12 is 8. So then if 1 over 8 equals to 1 over r to the power of 6, I can flip it. Flip it means r to the power of 6 now equals to 8. So that means if a equals divided by b equals c divided by d, then that means I can flip it. B over a must equals to d over c. It's exactly the same thing. So now, good. Now I've come to here. Well, then some of you say, oh, well, what is that? Well, let's see this, okay? So I find this kind of number sense is very interesting. So this one means r to the power 6 equals to 2 to the power of 3. All right? So we talk about that if the power is the same, then the base must be same. So I have to make the power here. I have to make these two powers equals the same. Then by doing what? Well, by doing, I'm going to say that is root of 2 to the power of 2 and to the power of 3. How about that? And r to the power of 6. So then now we can say, okay, so that means r to the power of 6 equals to root of 2 to the power of 6. Oh, well, then that means the base has to be the same. But note, because it is an even power, it's an even power here. Therefore, both the positive and the negative root of 2 will give you the same result. So therefore, my r equals to positive negative root of 2. Oops. Oh, I guess I have to somewhat go back to this one again. Oh, this is not good. What's going on here? Well, don't worry about this. Let's see whether or not I could just erase this thing, but it doesn't matter, we're already here. Oh, okay, very good. So then that means, let's go back to here and here. So that means that equals to positive and negative root of 2. Okay. There's another student asked a question in the word questions. Now here, just a note, okay? A car calls, this is a very, very classic, typical question for arithmetic, geometric sequence. This type of depreciation, appreciation. So here, what's the value after 5 years? All right. So it's very easy to say, and I did the same mistake. Easy to say, okay, after 5 years, that means the a to the 5. So that means the a1 multiplied by that to the power of 4. And that's not correct. Why? The reason why is I think sometimes if we write out either diagram or something for our understanding is much, much better. So at the beginning, the cost is 40,000. All right, so each year, so that means there's 1 year, there's 2 years, there's 3 years, there's 4 years, and after 5 years, that means from here to here, there's 6. So that means this one is 5. All right, so this is just one thing to pay attention to.